Welcome to my channel. In this tutorial, we will be discussing introduction to practical electronics. We will discuss basic electricity, forms of electricity, AC, DC, pulsating DC, talk about voltage, current, resistance. Then we will also cover electronics, basic electrical components. We'll be discussing introduction to practical electronics. First on our list is electricity. What is electricity? Electricity is simply the movement of charges through a conductor or a semiconductor. What is a conductor? A conductor is any material that allows electricity to flow through it easily. What is a semiconductor? A semiconductor is a material that partially allows electricity to flow through it. What is insulator? Insulator is a material that does not allow electricity to flow through it. So here we've had an idea of what electricity is. That is the movement of charges through a conductor or a semiconductor, through a circuit. Now we have a conductor, semiconductor, and insulator. A very good example is this. This is a metal. This is a conductor. You can see this is a conductor. It allows electricity to flow through it easily. This is an insulator. What you have here, this is an insulator. This does not allow electricity to flow through it. Here we have semiconductors. This is a semiconductor. So semiconductor have properties between conductor and insulator. So this partially allows electricity to flow through it. You understand? Here we have static electricity. Then we have current electricity. Those are the two forms of electricity we have. Now, what is static electricity? Static electricity is a type of electricity that does not involve the movement of charges. The charges stay on surfaces of materials. For example, if I use this pen and rub it on my hair and I bring it close to a piece of paper, it's going to attract it. Why? Due to the presence of static electricity. Then we have current electricity. Current electricity is the type of electricity that involves the movement or flow of charges. So this is the type of electricity that we use in our homes, in our vehicles, or in our industries. So in this one, the charges flow through conductors or through semiconductors. While here the charges, they just stay on surfaces of materials. So let's talk about voltage, current, and resistance. So what is voltage? Voltage is an electrical force or pressure that pushes the charges to move through a circuit. So that force that pushes the electrons, that makes the electrons to move through the conductors, through the semiconductors, or through a circuit. So that force is known as voltage. Then what is circuit? What is circuit? Circuit is simply a path in which the charges flow through. So that's why we have electrical circuit. So let's look at current. What is current? Current is the rate at which the charges flow through a point in a circuit. So current there you are dealing with the amount of charges that are flowing through a point in the circuit. That's the rate at which those charges flow. So that's it, is a current. The voltage we are talking about, the force that pushes the charges to move, while current is the rate of movement of those charges. So you can see the voltage, you can see the difference between voltage and current. You understand? So let's talk about resistance. Resistance is simply the opposition to electric current in a circuit. That is, resistance is that force that opposes the movement of the charges. So it's referred to as resistance. Now let's look at the units of voltage, current, and resistance. Now voltage is measured in volts. You can see the letter V used to represent volt. The symbol is V, so we use this V for voltage. Current is measured in amperes. You see the letter A. So the symbol is I. So in a circuit there, when you see V, you know that it's voltage. When you see I, you know that it's current. You understand? So these are the units. Voltage, we still use V. While in amperes, A. That's for current. For example, now you can say 25 volts, 30 volts, and then you can say 5 amperes, 6 amperes, 7.1 amperes. You understand? So when you are drawing a circuit, you use these symbols. When you see this in a circuit, you know that it's voltage. When you see this I, you know that the movement of current. So what about resistance? Resistance is measured in ohms. You see this symbol here, this omega symbol. You can look at it here. So you use as the unit in ohms. Then the symbol is R. So when you see R in a circuit there, you know that you are referring to resistance. So what are the instruments that are used for measuring voltage, current, and resistance? Voltage is measured with a voltmeter. So the instrument we use in measuring voltage is called voltmeter. Current is measured with an ammeter. Resistance is measured with an ohmmeter. So look at this instrument here. This instrument is called multimeter. Multimeter. You can use it to measure voltage, current, and resistance. So that's why it is called multimeter. That's 3 in 1. Look at this. This is for measuring DC voltage. We'll be talking about DC voltage and AC voltage. While here, this side is used for measuring AC voltage. You understand? Then when I turn it down this way, you can see this range is for measuring resistance. You can see the ohms, the unit there. You can see ohms. You can see it. So this is a multimeter. It has other features also. So you can see. Then look at this side. You can see A. This is for current. So you can see. So this meter, that's what I call this multimeter. You measure current. Two types of the voltages there, AC voltage and DC voltage, and then we have resistance. So you can see. So this is called multimeter. So I suggest you try and get this for your practicals. So let's talk about forms of electricity. So what are the forms of electricity? We have alternating current, alternating current, AC. So what is alternating current? Alternating current is a form of electricity in which the current changes direction periodically. You see, the voltage changes direction. You understand? The voltage changes direction. Then what about DC, direct current? This is a form of electricity in which the current maintains a steady direction. Now let's go back to our meter here. You can see the sign of this of AC. You can see this is sine wave. What you see here. Then look at the symbol for DC. You see a bar with some dots underneath it. You understand? This one is sine wave. So here we know it's AC. So when we want to measure AC voltage, we use this. When we want to measure DC voltage, you understand? So in DC voltage, the current does not change direction. In AC voltage, the current changes direction periodically. You understand? While in DC, the current maintains a steady direction. So that's why we have positive and negative. We don't use positive and negative in AC voltage. So take note of this. We use positive and negative on DC voltage, because why we can't use positive and negative in AC is that the positive will be changing to negative, the negative will change to positive continuously. So we can't say this is positive and this is negative. That's what we call alternating. It alternates. So that's the difference between the AC and the DC voltage. Then there is another third one again called pulsating DC. Pulsating DC. This is a form of electricity in which the voltage switches between the maximum and zero rapidly at a particular frequency. So you see the voltage will come on and then it will go off. It will come on and it will go off like that. That's between the maximum point and zero. For example, now the voltage comes to 5 volt and it goes to zero. It comes to 5 volt and it goes to zero at a particular frequency rapidly. So that's pulsating DC. You understand? Now, where can we find this pulsating DC? Is used in our power supplies, our laptop charger, our phone chargers. Pulsating DC is used there. Then what about direct current? We find direct current, we get direct current from our batteries and our solar panels, and also our AC to DC rectifier. You understand? That's where we get direct current. Then now about alternating current. Alternating current is one coming from our grid supply and also from our gasoline generator. So that's places we get AC. You understand? So you should know these three: alternating current, direct current, and pulsating DC. So let's look at sources of electricity. So just like I said earlier, in DC voltage, you get them from solar panels, batteries, AC to DC converters. So those are places you can get DC voltage. Then what about AC voltage? Hydropower systems, that is the one supplied by our grid, our national grid. Then we have petrol or gasoline powered generators. They also have some wind turbines. There are wind turbines that produce their generators are DC, while there are some their generators are AC. So all these are sources of where we can get DC and AC. Then pulsating DC are from square wave oscillators. So there's something called square wave oscillator. Is simply a circuit or device that what produces waveforms. It could be sine wave, it could be square wave, it could be triangular wave. You understand? So there are square wave oscillators and generators. Those the circuit that generate this square wave. So that's where you get pulsating DC. So pulsating DC is used inside our laptop chargers, our phone chargers, to cut down high voltage DC into low voltage DC. You understand? So at high frequency, so those where we use where those places where pulsating DCs are used. Now we find this inside our computers, even inside your phone. You understand? Inside your phone, we see how this pulsating DC is very, very important. Our computer system, the digital systems, they make use of this. You understand? So let's look at electronics. Let's look at electronics. We've talked about electricity. We know what electricity is. So now let's ask ourselves what is electronics? Electronics is a field of science and technology that deals with the controlling and passing of electric current through different semiconductor materials interconnected to achieve a desired behavior or effect. So you understand? So that's what the electronics is. You know, electronics, those semiconductors. So all this stuff you see here, all these things, they are semiconductors. So we're going to talk about them. All these are semiconductors. So once you have this in a circuit, you understand? Like what you are seeing here, you can see those semiconductors. So this electronic circuit, this is called electronic circuit. So you see, it's electronic circuit. This is a circuit board. This is my programming board that I built. You can see semiconductor. So this is called electronic circuit board. You understand? So let's take a look at this. Electronic appliances and electrical appliances. So we need to know the differences. So your TV is an electronic appliance. Your camera, mobile phone, computer, PC, DVD, there are so many. The electronic appliances. The one about electrical appliances, electric stove, AC fan, DC bulb, AC water heater. Now, when you talk about the electronic appliances, they are made up of all these semiconductors, which we are going to talk about them very soon. All these things, semiconductors, stuff that are made up of this, they are electronics. Now, in your electric stove, you don't see anything like semiconductors there, just pure heater with switches. So you can see your fan, you have some coils and wires. So you can see. So you know the difference between the electrical and electronic appliances. So let's look at basic electrical components. Let's look at basic electrical components. So we're starting with resistor. Resistor is a symbol, resistor. So what is a resistor? So a resistor is simply a semiconductor device that limits the flow of current. So you can see, so that's a resistor. That device that limits, we talk about resistance, which is the opposition of the flow of electric current through a circuit. So that device that does that, that offers that opposition, is called the resistor. So what are their symbols? Any of these symbols you can use. So they are symbols of resistor. So let's look at how resistors are. So let's look at, so here we have resistor here. So this is a resistor. So you can see it. So this is a resistor. So you can see them. So you can see where we use resistors here. You can see the resistors. So you can see them. So these are resistors. So we have types of resistors. Types of resistors. We have fixed resistors, like this one we have here. This is a fixed resistor. You understand? Then we have a variable resistor. So this is a symbol of variable resistor. So we have different types of variable resistor. We have this one called potentiometer. You can see this potentiometer. This is variable. You can see it has 3 terminals. You can see the middle terminal and the two outer terminals. So this is the symbol. You understand? Then we have other ones, LDR. LDR, I have one here connected. This one here is it is covered. This is an LDR that's here. The light dependent resistor. I've already connected it, soldered it, so you can see this is LDR in here, light dependent resistor. So you see, so it's the value of the resistance changes with the intensity of light. Once there is change in light condition, the resistance changes. Why this one, you mechanically you vary resistance with a screwdriver, or those ones that have long shaft. Then we also have a thermistor. We also have thermistor. That's a temperature dependent resistor. You understand? We find this in our vehicles, our refrigerators, some microwave ovens, our heating systems. We will find this thermistor. This is temperature dependent. Now this is light dependent. Why this one temperature? As the temperature changes, the resistance changes. Now there are two types. There's PTC and NTC. PTC stands for positive temperature coefficient. That is, increasing temperature will lead to increasing resistance. While the NTC, negative temperature coefficient, stands for that is the increase in temperature lead to decrease in resistance. Then we have one now called load cell, like those digital weighing scales we have in our physics and electronics lab. So they are made up of load cell. They're far away now, I've shown you. Then we also have another ones called varistor. They also have flex sensor. So all these are types of resistors. So let's look at capacitor. So what is a capacitor? A capacitor is simply an electrical device that stores electric charge. So that's a capacitor. So these are the symbols of capacitor. We have this non-polarized and polarized capacitor, and this variable capacitor. So look at this. This is a polarized capacitor. You can see. So look at it. Then we have non-polarized capacitor. So we'll be using these capacitors in most of our practicals. So this is polarized. Why this is non-polarized? So this one we have here, this is non-polarized capacitor. Why this? This is non-polarized capacitor. Why this is polarized capacitor? You understand? This is non-polarized in the sense that you can connect it either way. You understand? Then this one is polarized. You cannot connect it anyhow. It has positive and negative. So if you look at the capacitor very well, uh, you see this black. There's a stripe there's a mark on it. So if you look at this mark you are seeing here, this is negative terminal. You understand? This is negative terminal. So you see a sign here. So this is polarized. This is friendly polarized, and the non-polarized capacitors. You understand? The polarized capacitor, the value are printed on it. You understand? The value is printed on it. Like look at this one here. We have 1 microfarad. You can see this one is 1 microfarad. Then this one they use code numbers on this. They use code number. When you see 104, it means 0.1 microfarad or 100 nanofarad. We'll be discussing that sometimes. So these two forms of capacitor, we'll be using these ones a lot in our practical. These two, we'll be using them a lot in our practical. Then here we have variable capacitor. Now this type, you can vary the capacitance. You understand? You can vary the capacitance. These ones they are fixed. This one is variable. So let's look at diode. What is a diode? A diode is simply a semiconductor device that allows electric current to flow through it in one direction only. So you can see the symbol of diode is a symbol. It has positive and negative, anode and cathode. So let's look at an example here. So this is an example of a diode. You can see. So if you look at it here, you can see this mark on it. This is the direction which current flows. Current flows through this way, from the positive to the negative. So to allow current to flow in this direction only, if you push current through this way, it's going to block it. So you understand? So this is a diode. So these are a diode. There are some smaller than this, while there are some larger than this. Let's look at another one. Yeah, you can see this one also. So this also is a diode. There are some that are even smaller than this. So these are diodes. So you understand? So we also have types of diode. So let's look at types of diode. We have light emitting diode, the one that emits light. Light emitting diode, like this. So you can see it's going to emit light once light shine on it. So this is LED. So that's the symbol. You can see the symbol, you can see the arrow going out. You understand? Then we have photodiode. We don't have that one here with me. Photodiode, the one that light, when light shine on it, current will flow in that direction. So that's photodiode. When light shine on it, current will flow in that direction. Why this one? When current flows in that direction, it will emit light. You understand? Why this one? When light shine on it, it will allow current to flow. So that's photodiode. Then we have Zener diode. We have Zener. Let's look. We have Zener diode here. So this is 5.1 volt Zener diode. You understand? This is 5.1 volt Zener diode. So you can see the symbol. You can see the symbol here. So this is a Zener diode. You understand? Then we have infrared diode. Infrared diode is you look at this diode, you see on our infrared remote controls. These are infrared diode. Now there are two types. There is one that emits infrared rays, while there is one that receives infrared rays. So like this one, remote control is the type that emits infrared rays. So let's talk about transistors. So what are transistors? So what is a transistor? A transistor is a three-terminal semiconductor device that is used to control or amplify electric current in a circuit. So that's what transistor does. The sound here on our power amplifiers, the works of transistors. Types of transistors. We have bipolar junction transistor, BJT. You can see their symbol, the NPN and PNP. Let's take an example here. So this is an NPN transistor. Understand? We also have another. Let's check one other one here. We have another one. This is also NPN transistors. You can see them. Some are very big, some are very small. So these are transistors. So this is NPN and PN. These two are NPN transistors. How do I know there is a number written on it? Check that number on your data sheet. You will know what type of transistor is it. So look at these two. We have PNP and NPN. I don't have the PNP here with me right now. So you see this B, C, and E. Look at the direction of the arrow. Look at the direction of the arrow. So you differentiate them. B stands for represent base. C represent collector. E represent emitter. So you see. So this direction, current flows through this direction. Current flows in through here. current flows in through here and then the current comes out from here. Why this one, current goes in from here and it goes out from here and it goes out from here. So that's the difference between the PNP and the NPN. Then we have another type, field effect transistor, FET. You understand? So under the field effect, we have MOSFET, metal oxide field effect transistor. So these ones, their pins are known as gate, drain, and source. Gate, drain, and source. We have the N channel and we have the P channel. So this is the drawing. You can see the drawing is different from the BJT. So let's have an example here. So this is a MOSFET. So this is a MOSFET that we have here. So this is a MOSFET, metal oxide field effect transistor. So we use this in our inverters and charge controllers for high current switching devices. Then also we have a JFET, junction gate field effect transistor. So this is their symbol. So let's look at transformer. What is a transformer? We have been seeing transformers. So what is transformer? It's an electrical device that is used to increase, step up or decrease, step down AC voltage at a fixed frequency. This is the primary. The primary is the input side where voltage is fed in, while the secondary where voltage is given out, where voltage comes out. So what you are seeing here is the coil, the copper coil. So here the number of the turns of the copper is higher than here. So here the voltage that will be coming out here will be lower than this. So that's step down. While this one is step up, you see the coil, the winding here is less than the winding here. So the input voltage here now, the voltage will be higher than this point. So this is known as step up transformer. So we also have types of transformer. Types of transformers. We have ferrite core transformer, high frequency. These types are used in our phone charger and our laptop chargers. And then some power inverters, they use this high frequency transformer. Then we have the iron core, the heavy ones, those made with iron core, for low frequency. The one which commonly we are used to. So they are iron core transformers. Then we have audio transformers using some audio amplifiers. Then we have current transformers. We have voltage transformer. The voltage transformer is the one commonly we are familiar with. Those are voltage transformer. Then the current transformer is used for measuring current. You understand? Then we also have auto transformer. The type inside our voltage stabilizers based on the winding. So the auto transformer. Then we also have variable transformer. Variac, the one in which the voltage can be adjusted, can be controlled. Let's look at inductor. Inductor. So what is inductor? An inductor is simply a device that stores and releases electric energy in its magnetic field. Understand? So that's inductor. This is the symbol. Then look for inductor here. Oh, I didn't come with any. So we have one here. So inductor. So these are inductor is. So this is inductor. So also let's take a look at some other useful items. We have push buttons. This is push buttons. It's also push button. You understand? We also have all this voltage regulator. We have here, this is buzzer. we'll be doing practicals with a lot of this. We're going to talk more of that. So thank you. See you in our next video.